Okay, here's the warm-up. So we're just going to solve these equations. For number 1, you're going to distribute the x, or the 5 into the x and the minus 2. So 5x minus 10 plus 4 equals, distribute the 2, 6x plus 2. Combine these like terms, 5x minus 6 equals 6x plus 2. Subtract the 5x. Subtract the 2. And x equals negative 8. Go to number 2. This can be written as 1/4. This can be written as 3/4. Since both fractions have a 4 in the denominator, I'm going to multiply everything by 4. So the 4 would cancel here, I'd get 1. The 4 would cancel here, I'd get 3. Keep the parentheses without multiplying by the 4, and the 4 does go across to the 3, so that's 12. 1 plus 30 minus 3x, 1x, equals 12. Negative 2x plus 30 equals 12. Subtract the 30. Negative 2x equals negative 18, and x equals 9. This is the same as the question on the homework, so I actually worked it out by keeping these as decimals at the end of the video. If you want to fast forward all the way to the end, I did that. In that case, you would multiply everything by 100 to get rid of the decimal. All right, the number 3, distribute 2x plus 2 equals 2x minus 1. It's almost an identity, but they're not exactly the same. When I subtract the 2x, they cancel, and I get 2 equals negative 1, which is definitely not a true statement. So this is a no solution or does not exist question. So 1, 2b, these are like the longest sections, so we have to split in A, B, C's. But 1, 2b is solving rational equations. So rational equations, if you remember, rational expressions are ones with denominators that have fractions in them, that have variables in them specifically. Now we're putting those inside the equations. So the things we're going to do are eliminate those fractions, kind of like what we did with yesterday's stuff. We're going to figure out what the least common denominator is, and then we're going to get rid of it by multiplying each term by that least common denominator. The big thing here is these answers must be checked. So yesterday's stuff, we said if you wanted to, you had the extra time, you could check your answers. But when there's a variable in the denominator, that's why it's different, you have to check these answers. You don't have to plug them in completely, but what you do have to do is plug them into the denominator and see if it would give you an undefined answer, which would mean your denominator is 0. If that's the case, we call this an extraneous root, and it means you cannot use it. So if my denominator is 1 over x, and my answer at the end is x equals 0, I could not use that, because if I plug 0 in here, it makes it undefined, right? If my variable in the bottom was x plus 1, however, and I get an x is 0, that's fine, because if I plug 0 in here, I get 0 plus 1, which is 1, and 1 can be in the denominator, okay? So it's just the values. Remember we talked about this like domain like 2 weeks ago, right? And I said we would come back to it. We're just know it's there. This is why, okay? So in the denominator, whatever you get as an answer, you're going to check back by plugging into the denominators and making sure none of them would give you zeros. Okay, so here's some examples. We're going to start with just the numbers. Notice 1, 2, and 3 just have numbers in the denominator. Those you don't have to check, okay? Those you can check with extra time, but you don't have to check them. There's not going to be an extraneous root with those. But as soon as you get to number 4, where you see variables in the bottom, these are the ones you must check, okay? So we're going to start with number 1, okay? Look at the denominators, which are 3 and 4. What would be the least common denominator? 12, good. So my least common denominator is 12. I'm going to multiply every term by 12. So like I did yesterday, I'll write this first step out this time, but I'm not going to write it every time because you don't need to. But I multiply 12 over 1 by every term that's there, including the 2 on the other side. So that's a big one people forget. Now, if you've done the right least common denominator, this next step will cancel out your denominators. So 3 goes into 12 4 times. 4 goes into 12 3 times, and 2 and 12 already don't have a denominator. That's 24. So in the first one, I get 4 times x, which is 4x over 1, plus 3 times 3x, which is 9x, equals 24. I get 13x equals 24. Divide both sides by 13. And x is 24 over 13, which can't be reduced, okay, and does not need to be in mixed number form. You can leave it just the way that it is. And again, if there was a variable in the bottom, I'd make sure when I plug that back into the bottom, it doesn't give me 0, but right now there's not a variable in the bottom. Everybody good on that one? Yeah? We good from home? Okay. 2, 5, and 3, what's my least common denominator? 15. Good. So I'm going to multiply everything by 15. So I'm not going to do that step one at a time, but if you need it, do it. So 15 would go into, 5 would go into 15 3 times. I'd get 3 times 2x. 5 and 5x times 15, you're just going to multiply. And then 3 goes into 15 5 times, so you're going to get 5 times 4. I'd get 6x plus 15 times 5, which is 75x equals 20. I get 81x equals 20. Divide both sides by 81. And x equals 20 over 81. Everybody still good? Yes. Audrey, where are you at? You better not be sleeping.
I'm not. I'm
You and Ethan asked questions yesterday. I was used to hearing your voices. Just make sure you're staying with us. Okay, 3, you do. So figure out the least common denominator and then multiply it. Four is the first one that actually has a variable in the denominator. So this is where we have to make sure we go back and check our answers, okay? If when you're doing your work, like if you get your homework and you want to make sure you put a little note for yourself, it's anytime there's a variable in the denominator, you've got to check, okay? Because for sure, if this is, and I don't know what it's going to look like, we don't have it yet, but let's say the next quiz or test is multiple choice. Whatever your answer is, if it's an extraneous root, will be an option. You'll get working, you'll get excited, you got to the answer, it's there, you'll pick it. And then another option will have been no solution, which is what really it should be if it's an extraneous root. So just be really careful. All right, so this time I only have one variable, right? It's just x. So x is my least common denominator. So I'm going to multiply x over 1 times 15 over x. And then x times 4. And then x over 1 times 6 over x. And then 3 times x. So these x's cancel, and I just have 15 minus 4x on the left. On the right, the x's cancel, and I get 6 plus 3x. Then I want to move the x's to be on the side together, so I'm going to add the 4x. And then I'm going to subtract the 6, and I get 9 equals 7x. Divide both sides by 7, and I get x equals 9/7. Then I need to check. So I do not need to check as in go through the whole process. You can if you've got the time to check your answer. What I do need to do is go back here and see what would have made those undefined, right? So if x is 0, my function would have been, or my equation would have been undefined, right? Is this 0? No, so it's fine. So I keep that answer, okay? If I had gotten x as 0 for the answer, I would have said that that's an extraneous root, and so there's really no solution. Everybody still good? Yeah. All right, now the denominators just get a little bit more complicated. My advice on something that only has one fraction on either side of the equal sign is cross multiply. Okay? It's easier than finding a least common denominator and multiplying it. If you only have one fraction on either side of the equal sign, like this one, cross multiply. So I'm going to multiply 2 times 10x plus 3, and I'm going to multiply 1 times 5x plus 6. So I get 20x plus 6 equals 5x plus 6. Subtract 5x from both sides. Subtract the 6. Divide by 15. 0 divided by anything is 0.
Wait, can you go over that one?
Sure. So what I did from the beginning is if there's only one variable on either side of the equal sign, you can actually just cross multiply. So I multiplied the 2 times the 10x plus 3, and I multiplied the 1 times the 5x plus 6. So on the left-hand side, distributed the 2 to 10 and 2 to 3, and I got 20x plus 3. On the right-hand side, distributed the 1 to 5 and 6, so it stays the same. Then subtracted 5x from both sides, subtracted 6 from both sides, and I end up with 15x equals 0. Divide both sides by 15. 0 divided by anything is 0.
Was that the answer? Is the answer D?
So that's what we're going to check now. So if this was the last question, there would have been no solution, right? Because x was by itself in the denominator. But the only denominator that has a variable here is 5x plus 6. So that is what cannot equal 0. If I solve for x, the only answer that would give me an extraneous root is negative 6/5. Did we get negative 6/5? No. So we can keep the 0. So the rule is not that x can't be 0. The rule is that when you plug it back in, your denominator can't be 0. Does that make sense? Yeah.
So
Yeah.
why would it, if your denominator can't be 0, why is negative like 6/5?
Because that's what makes this 0. If my answer had been negative 6/5 and I plugged it in, right? These would cancel. I would get negative 6 plus 6, and I'd have 0 in the denominator. So you can choose. Either take your value, plug it in, see if you get 0. If you don't, you're fine. Or take your denominator at the beginning, set it equal to 0, and say that's what it can't be. That's the restriction, which is the domain restriction that we talked about at the beginning of the last chapter. Not the beginning of the last section. Any questions on that one? Okay, so go to 6. 2 things to do here. One is least common denominator. Those are different, so I could say that the least common denominator is x times x minus 5, and I could multiply all 3 of those fractions by it. I can also say, because this is equal to 0, move this to this side, and then cross multiply. So you have both choices, okay? You do whatever works for you. So I'm going to work through that first method because we haven't done it yet with these denominators, okay? But you could also cross multiply. So I'm going to take these and I'm multiply it times x and x minus 5. So x times x minus 5 over 1 times 1 over x plus x times x minus 5 over 1 times 1 over x minus 5 equals 0 times x minus 5. So on the left-hand side here, the x's are going to cancel. X minus 5 times 1 is x minus 5. Plus x minus 5's cancel. 1 times x is x.
Wasn't it 2?
Oh, thank you. 2. This is 2. Two times x is 2x equals 0 times x minus 5. 0 times anything, doesn't matter, it's 0. Then combine your like terms. 3x minus 5 equals 0. 3x would equal 5, and x would equal 5/3. With me so far? Now go back to your question. If I set this equal to 0, then my restrictions from the beginning are x cannot equal 0, And I set this one equal to 0. X can also not equal 5. So this, either of those answers would have been extraneous, but neither of those are here. So I keep my answer. Still good? Yeah. From home, still good? Yeah.
Yes.
Thank you. I saw her in the hallway and I'm like, Audrey, you're so tall. She's like, I know. I'm like, I didn't expect that. All right, 7. What's your least common denominator now?
2x plus 1, 2x minus 1.
Good, it's both of those. 2x plus 1 and 2x minus 1. So I multiply 2x plus 1. And actually, I'm just going to do it the shorter way. You don't have to write it out every time. I'm going to do it here. Okay? 2x plus 1 and 2x minus 1. So from that first one, the x plus 2x plus 1s would have canceled. I'd have to multiply 7 times 2x minus 1. From the second one, the x minus 1s would cancel, and I'd have to multiply 8x by 2x plus 1. And then from the on the other side of the equal sign, I have both because neither cancels. So I'd get 7 times 2x minus 1 minus, because that's the sign in between, 8x times 2x plus 1 equals negative 4 times 2x plus 1 times 2x minus 1. Then I've got to distribute all that out. So the 7 gets distributed, 14x minus 7. Negative 8 gets distributed, negative 16x squared minus 8x equals, this is a special product. If you catch it, it's the difference of two squares, right? So if I were to FOIL that out first, instead of going 4 into that one and then the second into the third, I would get 4x squared minus 1. Then I distribute the 4, negative 4, and I get negative 16x squared plus 4. Question so far? Okay, now I gotta combine my like terms. So I'm gonna do negative 16x squared is the only x squared on this side. Positive 14, negative 8 is positive 6x. And then the 7 minus 7 is by itself. Negative 16x squared plus 4. Now I got an x squared to worry about, but if I add that 16x squared to both sides, it cancels out. 6x minus 7 equals 4. Add the 7. 6x equals 11. Divide by 6. And x equals 11 over 6. Now there's my answer so far. I got to go back and check, right? So set each of these equal to 0. For the one on the left, x cannot equal negative 1/2. For the one on the right, x cannot equal positive 1/2. So my 11 over 6 is fine. I get to keep it.
I'm a little confused on the check-in thing.
Say again?
I'm a little confused on the check-in.
So you're good on the 11/6, yes?
Mm-hmm.
Okay, so once you get your answer, you have to go back to the original question, which is super messy. Let me clean this off so that you can kind of see what it was like at the beginning. You have to go back to your original question and look at all of the denominators. That's all I'm worried about, because I can put 0 in the top and I can get a number. 0 is an answer. I can't put 0 in the bottom. If you divide by 0, and if you ask Siri, she'll tell you something about Cookie Monster, having 0 cookies and no friends. Yeah. If you put 0 in the bottom, it's undefined. So we would try to figure out what answers we can't keep by setting each of these denominators equal to 0. So I would solve the first one by doing 2x equals negative 1 and then divide by 2, and I'd get x equals negative 1/2. That's what x cannot equal, because that would mean there's a 0 in the denominator. Do the same thing with the one on the right. I get x equals 1 and x would equal 1/2. Again, that would be what it cannot equal. So if you want to do that from the beginning and put a little note for yourself, you can do that at any time. But then when I get to my answer, that 11/6, I have to make sure that that's not 1/2. If it was 1/2, I would rule it out and say there's no solution.
Okay, so 1/2 is just like the thing that, like, is there the thing that you just can't have?
Correct.
1/2?
Yep. They call it a domain restriction is what it is, or a restriction.
So 1/2 and 0, they can't equal?
1/2 and negative 1/2.
Okay.
Yeah. Okay, let's do another one. What's different this time? They added a step for us, right? There's 3 denominators and the third one can be factored. Yes? So this is x plus 2, x minus 2. My least common denominator is x plus 2, x minus 2. I'm going to multiply that times each term. So from the first one, the x minus 2's cancel, and I have to multiply 1 by x plus 2. From the second one, the x plus 2's cancel, and I have to multiply by x minus 2. And from the last one, they both cancel. So I get just the 6x. So my numerator in the beginning is 1 times x plus 2, or x plus 2, equals 3 times x minus 2, or 3x minus 6, minus 6x. Combine your like terms there on the right. Negative 3x minus 6. Get the x's to one side, so I'm going to add the 3x. 4x plus 2 equals negative 6. Subtract the 2. And divide by 4. X equals negative 2. Good so far. Go back to the question.
Yeah.
Thank you. Go back to the question. Look at my denominators, right? If I were to set each of them equal to 0, the first would tell me x cannot equal 2. The second would tell me x cannot equal negative 2. And the third, it can't equal negative 2 or positive 2. But we got negative 2, so that's an extraneous root. That actually cannot be used. My answer is no solution, and on WebAssign it's DNE, does not exist. You could put a 0 with a strike through it if it was a short answer. You could put no solution, okay? On WebAssign it wants DNE. Everybody still good? Oh,
Yes.
okay. All right, last slide. So 9 only has one denominator. I'm going to multiply everything by x minus 4. From that first denominator, it's going to cancel, and I get 3x. 5 gets multiplied by x minus 4. Second denominator, it's going to cancel, plus 12. Distribute the 5. Combine my like terms. I can subtract the 5x, negative 2x equals negative 8. Divide by negative 2, x is 4. What can x not equal from my original equation? Good, positive 4, which means I rule it out. No solution. Does not exist. What time do I have until 8:40? Okay, I'm going to actually skip to 11 and then I'll go back to 10. So 11, we're back to factoring again on the denominator. So this becomes x plus 3x minus 2. Now my least common denominator is the combination of those two, x plus 3, x minus 2. So I'm going to multiply everything by those. The x minus 2's cancel, and I have to multiply by x plus 3. The x plus 3's cancel, and I have to multiply by x minus 2. Both cancel, so I don't have to multiply 4 by anything. 1 times x plus 3 is x plus 3. Plus 3 times x minus 2 is 3x minus 6 equals 4. 4x minus 3 equals 4. Add the 3 to both sides. Divide by 4. And x equals 7/4. Check your initial denominators. If x minus 2 cannot equal 0, then x cannot equal 2. If x plus 3 cannot equal 0, then x cannot equal negative 3. And then I don't have to do it again because they're the same in that last denominator. So I don't rule it out. I keep the 7/4. So same exact process, you just got to factor that one, okay? And then I'll go to 12 and then I'll go back to 10. You also have to factor 12. So on 12, that last denominator, you take out an x. Now my least common denominator is x times x plus 3. From the first one, I'm going to cancel out the x's, and I'd get 6 times x plus 3. Then it's a minus. From the second one, the x plus 3's cancel, and I'd get multiplied by by x, so it's 2x. And on the last one, they all cancel again, so I get 3 times x plus 5, just the numerator. Distribute. Combine my like terms. Subtract the 3x. And move the 18. And I get x equals negative 3. Go back to your initial equation. This would be x couldn't equal 0, so that's not a problem, but this is x cannot equal negative 3, and that's what we got. So we rule it out. No solution. D and B. Okay, that bell's about to ring if they do it on time. So I'll do 11 on the video. Okay, so for this question, I would say you actually have two choices. You can keep it in fraction form or decimal form, but just multiply by a multiple of 10 to get rid of the decimals. So because there's two digits behind the decimals for both of these, you're going to multiply by 100, the same amount of zeros you need to move it. So when you multiply 0.25 by 100, it moves twice, making this 25x. 0.75 becomes 75. Remember, what's inside the parentheses goes unchanged, but the 100 has to go to the 3, so it'd be 300. So then distribute the 75. Combine your like terms here. Negative 50x plus 750 equals 300. Subtract the 750. Negative 50 equals negative 450. Negative 50x. Then divide both sides by negative 50. X equals, so I can cross through a 0 because they both have one. Negative and a negative makes it positive, and 45 divided by 5 is 9. The other way to do it is these are pretty easy decimals to turn into fractions. You can make it 1/4 x plus 3/4 10 minus x equals 3. Then I can multiply everything by 4. So it would cancel here, I get x, cancel there, I get 3. Again, make sure you go across the equal sign, 12. X plus 30 minus 3x equals 12. Combine like terms here. Subtract the 30. Negative 2x equals negative 18. Divide by negative 2. And there's your 9 again. So you can choose to do it either way.